And so one thing I'm going to emphasize here is that if you're really comfortable with degrees, and this radians thing really throws you off, you can convert from radians to degrees at the very beginning, take care of whatever you're taking care of, and then convert back to radians. However, the problem with that is radians are used in certain formulas where the angle measure has to be in radians. And we've seen that with last lesson where arc length, where you define arc length as equals theta r, theta has to be in radians. So the best thing to do is to get comfortable with radians. Okay? What is one thing we know? Okay, so to get started on this one, this looks like it's more than pi. Is it more than 2 pi? Okay. What is 1 full revolution? What is the central angle measure of an angle that goes 1 full revolution all the way around in a full circle? What is that angle measure? 360 degrees, but in radians, what is it? 2 pi. Good. Very good. So 2 pi radians. So if we go all the way around, here, you would end up at 2 pi radians. Like the terminal side would be, you'd have an angle measure of 2 pi radians. Okay? So what I want you to think about is in terms of graphing this, remember I emphasized last lesson, maybe last 2 lessons, is that when you go around 1 full rotation, you can kind of take that rotation out of your mind and kind of set it aside. Because it ends up landing in the same spot. Right? It ends up being coterminal to what was just, say, 0 pi radians, right? If I go 1 full rotation, this is going to end up being an angle, if it were just 2 pi radians, is the same thing as an angle that has 0 pi radians. Right? Because it lands in the same spot. So let's think about this. Think about if you were to convert this. I want you guys to help me out. If we were to convert this into, let's say, a mixed number, where we have a whole value and then a fractional value. So let's say a mixed number. So what's the most number of times 4 can go into 9? We'll hold the pi off to the side. But 4 goes into 9 how many times? Twice. And then what's the remainder? 1. So this is the same thing as this. Would you guys agree that 9 pi over 4, or 9/4 pi, is 2 1/4 pi? Right? Just going to a mixed number. 4 times 2 is 8. 1 left over, so 2 1/4 pi. Yeah. Knowing this, you know 1 full rotation is 2 pi. So if you go 1 full rotation, you've gone 2 pi. And then what's left over? How many more pi radians do you have to go? Just 1/4 pi radians. So if you go 1 full rotation and then go a little bit more, go pi over 4 radians. Whoops. You would have the graph that you want. You have the angle that you want. And we say theta is equal to 9 pi over 4. In your textbook, they show it as one continuous spiral here, all the way to here. Same idea. Let me go ahead and grab the text. For those of you that have the textbook, you need some paper, take notes. What do you want? You want line paper?
Yeah. You have plain paper over there?
Yeah, I have line and copy paper. Yeah. You want line or copy?
Yeah, I want to both. I want to make the both.
There's paper over there. That's supposed to be which ones. So, chapter 5. So for those of you that do have your text, and you can see that if you look at something like page 487 and page 488, they show the spiral going around. For example, there's an example here, 9 pi over 4, which is this exact same problem here. They show the spiral going around, and then all the way around, and then all the way up a little bit more, pi over 4, where you have to go 1 full 2 pi, and and then pi over 4 more, and they go ahead and they graph it like this. And that would be it. Draw and label this angle in standard position. So it just keeps going around and around and around, no matter how large this was. If this was 19 pi over 4, okay, think about, okay, how many revolutions would that be if I started at 0 pi, started my initial side, if this said 19 pi over 4, just as an example, if I had 19 pi over 4, let's say that this is, I don't know, gamma. I know it's another Greek letter, but you're going to see alpha, beta, gamma, theta. They just mean just some unknown angle. You call that alpha or angle A. It's really called alpha, but it doesn't really matter. We're going to use Greek letters because a lot of this came from ancient Greece.
Who is a lot of us?
What's that?
A lot of us people?
What? You're going to see a lot of letters. You're going to see a lot of different letters.
Oh.
A lot of letters. Anyway, sorry, what are you talking about? Alpha, beta, gamma, theta. So here we have gamma. Yeah, the Greeks were, again, back to the ancient Greeks, why you see these things. So gamma is equal to 19 pi over 4. Let's think about if we had to do this one. What's a simplified version of this? First of all, let's do the mixed number thing again.
4.
Let's take out 2 pi. So how many times can 4 go into 19? 4 whole times, right? So 4, and then the remainder would be what? 3. So 4 and 3/4 pi.
No, it's like
4 and 3/4, yeah. Okay, that works. So 4 and 3/4, go around 2 pi, go around another 2 pi, you got 4 pi. Where would this guy land? Where would the terminal side land?
it's off. It's off from 1 to 3/4.
3/4 pi. This would land on 3/4 pi, which would be in the second quadrant over here. 1, 2, 3, 4. It would land over here. Well, because I know that this is 0 pi, or 2 pi, or 4 pi, or 6, 8. This is 1/2 pi. Right? This is pi over 2. Or if I had another 2 pi and a 4 revolution, which would be what? 4 pi over 2 plus pi over 2 is 5 pi over 2. This right here. Or if I do another 2 pi on top of that, 9 pi over 2. And there's an infinite number. You keep going around. Over here, what's this in radians? What's a straight line? Brianna, what's so funny? Okay, what is this? 3.5 pi? 2.5 pi radians. So let's figure this out. This is 0. 1 full rotation would be 2 pi, so what would half a rotation be? 1 pi. Good, so pi.
So it's just pi.
Pi radians, yeah. Hello. Thank you. Alright, so pi. Alright, Rihanna, what's another one it could be? If we did another full rotation. What's another one it could be? If we did another full rotation. What's another central angle that would, the terminal side would land right here? No, not 1.5 pi.
2.
Nope, not 2 pi.
3
pi. And the reason is because, again, how much is 1 full rotation? 2 pi radians. So it's, yeah, if we do it again, we add on another 2 pi, 1 full revolution, maybe 3 pi.
Are you here Friday afternoon?
I should be.
Like to what?
Off the top of my head, I should probably be here pretty late.
Okay, because I need help
Okay.
with this stuff.
Okay. I'm just adding 2 pi because 2 pi radians is 1 full revolution, 1 full rotation. I mean, I could keep listing these forever and ever and ever. With angles whose terminal side would end right here on this axis. And then over here, here's your 3/4 pi. Sorry, your 3/2 pi, right? Because 0 pi, 1/2 pi, pi, 1/2 pi, 2 pi, 2.5 pi, 3 pi, right? 3.5 pi, 4 pi, it keeps going on and on and on and on. Once you know the fact that a full rotation is 2 pi, you can figure out all the rest. Okay, that's 2 pi, that's 1/2 pi, that's 1.5 pi. And if you want to figure out all the repetitions, just keep on adding 2 pi. So for here, 4 3/4 pi. Okay, so 2 pi. 2 pi again is 4 pi. Now we just have to go 3 more quarter pi, and you'll land over here. Now you can take that 4 pi and kind of like set it aside and ignore it, and think about this is going to have the same angle. It's going to be the same angle or coterminal with an angle that is just 3/4 pi, which is going to end over here. So I'm just taking out repetitions when I do these. So if I did this, let's say I'll do this in red. This guy would end up over here. And this here, we'd say like gamma is equal to 19 pi over 4. And you could show the spiral of how you got there, which if you did,
Is that just an
it would,
example, or?
this is just a random example right here. So if I did this, again it would be, goes around once, around twice, and ends right here. I know it's confusing the type because I have 2 spirals going on, so apologize for the confusion. You don't have to.
Wherever it lands, that's where the arrow goes.
Yep, that's where your terminal side goes, the terminal ray, yep.
We always start from the right side.
What? Quantum theory? I don't know about that. Maybe. I have no idea. I don't know anything about
We
quantum
always
theory.
start from the right side, like half.
Yeah, so you always start, here's your initial side, and when it's positive, you go in this direction.
Oh, when it's negative, you go.
So let's say it was negative 19 pi over 4. No, it's very simple. 2 pi, no, sorry, negative 2 pi, negative 4 pi, you got negative 3/4 pi to go, you end up right here. We could try another one.
It's easy, but
Insert page before. Let's see, we'll do one more here. I want to make sure that we cover what we need to cover, but let's do one more. So you make it up, Brianna. You tell me what it is. So theta is equal to what?
Wait, where we start? Okay. 14 pi over 7.
Okay, so
No, not 7. 6.
Okay, so 14 pi over 6. So I have an angle measure that's 14 pi over 6. Okay? Again, I know one full rotation is 2 pi. I'm going to convert this to a mixed number so I can see if there's any 2 pi's that basically where it repeats. So if I go, okay, how do I write this as a mixed number? I know that 6 can go into 14 2 whole times with 2 left over, which is the same thing as 2 and 1/3 pi.
Oh, so you just
I'm sorry,
simplify,
Mike, no, wait, hold
simplify. And then it goes around the circle 2 times, right?
It's going to go around the circle 1 whole time because 2 pi radians is 1 rotation. So if I go, I know I'm going to go 1 whole rotation, which is 1 revolution is 2 pi. I have 1/3 pi left to go. This is 0 or 2 pi. This is 0. This is 1/2 pi. So 1/3 pi is going to end up somewhere like here. And then I just graph it.
Why do you make so big?
Wait, can you explain from the beginning, like after that?
I mean, it's point, yeah, point.
So you see that? So if I go all the way around here, that's 2 pi. Well, I only have 1/3 pi left to go. So boom, there it is. I'm done.
Can you explain how you got this number?
Oh, here? Yeah. So I converted to a mixed number, right? 6 goes to 14 2 whole times. 2 times 6 is 12, 2 is the remainder, so 2 and 2, 6 pi. And then just simplifying 2 sixths to 1 as a 1/3. They both have 2 in common, the top and the bottom.
So why don't you go around?
Because 1 full revolution is 2 pi radians, not pi radians. Yes.
So you see how it's like 14/6, and then it's like 2/6 right there?
Mhm.
Whatever the denominator was at the top, that's what it's gonna be.
Yeah, when you convert to a mixed number, you do, okay, the whole number of times is going here, whatever the remainder is over the original divisor, yes.
Well, how do you know when to stop in this swirl?
Well, good question. When I converted to a mixed number, when I did this example here, I chose one that was kind of significantly bigger.
Yep.
Well, it was 4 3/4 pi.
So it goes around 2 times.
Every 2 pi is 1 full revolution. So I did, okay, 2 pi again, which is 4 pi. I only have 3/4 pi left to go, so 3/4 pi and then done.
If you go back to the other one, so I can just see something. Like, you see how right there you did a whole revolution?
Yep.
So that's 1. That's always good. Like, if they didn't have, I just don't get why you stop like up there. Because that's third. Because look, going all the way up to the top is half.
Yeah, remember this is pi over 2. 1/2 pi. It's pi over 2. Or 90 degrees. This is 60 degrees.
Is that your answer?
Yeah, that's it. It's graphed.
You don't even have to draw that circle.
So theta equals 14 pi over 6. I like to hear that. It's good. Don't overthink it. It never changes. 1 full revolution is 2 pi radians.
Is this geometry?
This is a branch of geometry. It's just, yeah. Okay. So I want to go over quickly some examples from the quiz that I saw some mistakes being made. So for example, you had something like this in the quiz. You had a couple of these. You had 2 that were very simple linear inequalities. If I have this, x plus 6 is greater than negative x minus 5. So first off, I want to go ahead and I want to get all my x's on one side, get all my constants on the other. Add 6 to each side, you get to here. Subtract 6 from each side, you get to here, and then divide by 2, and you're done, you graph. Some of you were making things up, like you'd say, okay, 2x plus 6 is greater than negative 5, and then 2x plus 6 is less than positive 5, as if there was absolute value involved. But there's no absolute value involved, it's just a simple linear inequality. And I did give partial credit for, even if you made up some extra stuff. Yeah. Yes. Yes, you may. It passes it. As soon as someone gets back.
I was waiting on the match.
Yeah. Yeah. Okay. All right. So, any questions about yes?
You said you don't want us to simplify. It was a negative 11 over 2. You just want me to leave it like that.
Yeah, this is fine. Negative 11 over 2. It's fine. It's fully simplified.
You didn't matter if it was this, right?
Yeah, I think as long as you're
You know
right.
the printer?
I do repair, yes.
Second copy?
No,
I cannot copy.
not here.
Go to
Not
the
this room.
office.
What copies? And don't let me copy stuff?
So now if we're talking about angular speed, that's just how quickly the angle is increasing. So this has nothing to do with distance. If we're just talking about angular speed, we're just talking about how quickly that angle is opening, which is why it's just theta divided by time. So if you know that theta had increased, say, pi over 3 radians in 2 seconds, then you know that the angular speed was, what, pi over 6 radians per second. Pi over 3 divided by 2, pi over 6. So again, the fundamental difference, actual distance being covered, we're talking about linear speed. We're not talking about distance being covered, we're talking about angular speed. We're just talking about how quickly the angle is opening up. And let me give you a perfect example. Does anyone need more time on the slide? Okay. So this arc length we have from yesterday or Friday a Ferris wheel or say like a bike wheel and you have spokes. Okay, let's understand this. If I have something, you know, like those kids will put like those things on the spokes, those little plastic things. If you put those on here, and let's say they were fixed on here, someone's near the center of the wheel, and then you have one that's out towards the tire. This point, no matter how I rotate this, if I can spin this point will have a faster linear speed than this point, because they're always going to be in line, right?
Yeah.
Okay, this distance is greater than this distance. So their linear speeds will be different. This one will always have a larger linear speed, no matter how slow or fast I'm turning this, because it's covering a larger distance over the same amount of time. However, they will have the same angular speed because they're fixed on that one spoke. So the rate at which their angle is changing is the exact same, no matter whether you're here or out here. You see that? That this theta, that's the same for both. So here's a clear distinction, the fact that p sub 2, or point 2, has a larger linear speed than p sub 1, but they have the same angular speed. Okay, if you have to really go, hold on. All right.